Hey y'all, I'm Sam, and I'm a calculus and math tutor here on Wyzant. So today we're supposed to solve a Riemann sum. We're supposed to consider the region bounded by y equals 12 minus 3x, the y-axis, and the x-axis, sorry. Estimate the area of the region using a lower Riemann sum with 4 rectangles of equal width, which is really nice they tell us that. It's a big hint. And we're also supposed to draw a picture. So I have a nice graphing utility, but you might not have something so fancy on calculus test that you have to handwrite. So you might want to actually rearrange the y equals 12 minus 3x into negative 3x plus 12. And then it's a little easier to see that your slope, which is your rise over your run, is the negative 3, or your m. And then the y-intercept is the plus 12, or your b. So if you plot that, you'll get a linear function starting at this 12 here on the y-axis and going negative with a pretty steep slope of negative 3. Then if we're supposed to draw a Riemann sum with 4 evenly widthed rectangles, each rectangle is going to have a width of 1 because there's from 0 to 4 until you kind of cross through your axis again. And then you'll be bound by the right-hand side of each of these rectangles because it's the lower one because your function is decreasing. So your rectangle would definitely be bigger if you were to start at 12 as your value. But then unfortunately, it wouldn't be considered a lower Riemann sum. It would be over the function itself, and it'd be an overestimate, but we're going for an underestimate, hence these kind of gaps here. So we're going to have one that starts here, and then the next one will start a little bit lower, even lower, and then this last one I really shouldn't have drawn because it has an area of 0 because the height of the function is 0 at the lowest point. Cool. And we know that the total area is just going to be the area of all the little rectangles, and the formula for the area of a rectangle is pretty easy. It's just the width times the height. And another way to think about it is that it's going to be your x2 minus your x1, so 1 minus 0, for example, times the height at your x2. Oh, so I actually kind of messed up my formula here. Let me fix it. So my x2 in the first case was actually going to be f of 1. We got f of 2, f of 3, and f of 4. Cool. You'll notice that actually all of these have a factor of 1 in front of them, so I kind of distributed that out to the front, but of course that's unnecessary because multiplying by 1 is just kind of like multiplying by nothing. And I got 9 from the height at this point, 6 from the height here, 3, and then of course 0. So I got that my Riemann sum would have an area of 18. Lucky for us, well, typically Riemann sums are supposed to be an approximation of integrals, but we don't even need to use a fancy integral to kind of check our answer. We can actually just use the area of a triangle because we have a linear function and then perpendicular axes that make it really easy. So we have the exact area of the region is going to be 1/2 base times height, which you probably remember from like much earlier than calculus. And we've got 1/2 times the base, which is 4 long, times the height, which is 12 high, which is actually significantly bigger than 18, 24. But that makes sense because remember, we have these gaps because we did a lower Riemann sum. So this is our correct answer, and I hope that helps. Thank you.